Okay, so hopefully you're here because you're looking at this page and it says watch video rectilinear motion. I assume you've completed number 76. Um, just sort of to recap on this guy, you're going to start at acceleration. You will integrate that. You'll get a velocity function that has a plus c in it. You'll use the fact that the initial velocity v of 0 equals 0 to get rid of that constant. Then you'll integrate your velocity function to get position. Once you've got position, it will have a constant in it, and you'll use the fact s of 0 is 1800 to get rid of that constant. When you get done, you should get s of t equals negative 4.9 t squared plus 1800. And to find out when the rock hits the canyon floor, we find t such that s of t equals 0. So we'll set this expression equal to 0, and we should get t equals 19.2 seconds. If you check your answer in the solution manual on Prism, and I hope you check your answers on all of these, your solutions, in that solution manual, it does have an error. It says 9.2. It should be 19.2. Okay, what in the world is rectilinear motion, this thing that is in problems 82, 3, and 4? Well, it's nothing more than this position, velocity, acceleration problem, but instead of things going necessarily up and down as a result of free fall, this objects are moving right, which is a positive velocity, and left, which is a negative velocity, along the x-axis. The position function, which is usually s of t, in these problems you'll see is called x of t, because x of t is the position, where is this object along the x-axis at any time t. Okay, so this would be at like t equals 1, it's here, t equals 2, the x position maybe is whatever that is, 3. Okay, so we're moving right and left along the x-axis, but other than that, it's just position, velocity, acceleration. So if you're starting with a position function, x of t, to get to v of t, we would know that v of t should be the derivative of x of t. And to get to acceleration, a of t is the derivative of v of t, or the second derivative of x. The only difference between these problems and what we did previously is we'd called x s. So no big deal, not much of a change. We should know from our previous work then that if you start at acceleration and you want to get to velocity, you integrate. The integral of, written that wrong, velocity is equal to the integral of acceleration. And position is the integral of velocity. So those are the facts you're going to use. You're either going to work from the top down, from position to acceleration by taking derivatives, or the bottom up from acceleration, integrating to velocity, and then integrating again to position. I guess there is one problem where they start you right in the middle. So if you're starting at velocity, you'll take a derivative to get down to acceleration, but you will integrate to get the position. Okay, I'm going to do number 81. This problem right here as an example, and then you'll be doing 82, 3, and 4. So in 81, as we can see, our position function, x of t, is t cubed minus 6t squared plus 9t minus 2, and it's on the closed interval from 0 to 5. Okay, it just, in part A, it just wants our velocity and acceleration. So, part A, v of t will be x prime of t, which means v of t is 3t squared minus 12t plus 9. Okay, so not so bad. And a of t, I just differentiated my position to get those results. Sorry if you couldn't see that. And a of t, acceleration, is the derivative of velocity. So that's 6t minus 12. And you're done with part A. In part B, it says find the open intervals in which t is moving to the right. Now, a second ago, I said that movement to the right would be considered positive velocity. So what we're going to do is figure out when is velocity positive. So I'm going to take my velocity function here. First, I'm going to figure out when it's 0. So I'm going to take 3t squared minus 12t plus 9 and set that equal to 0. I can factor out a 3. That's 3 times t squared minus 4t plus 3 equals 0. And now I can factor this piece. This is 3 times t minus 3 t minus 1 equals 0. Well, 3 doesn't equal 0, so this equals 0 when t minus 3 is 0, which is t equals 3, or t minus 1 equals 0, which is t equals 1. Now do a little sign chart. We know we only have to go from 0 to 5 because it's a closed interval, so that's enough. Put in the fact that at 1 the derivative was 0, velocity was 0. And at 3, you got a value of 0. And now we can just pick points in the 3 intervals. You can actually use the 0 and the 5 because the function's well defined there. The easy place to stick this in is probably right here where you've got the factoring done. If you put a number like 5 in, 5 minus 3 is positive, 5 minus 1 is positive, positive times positive is positive. We know velocity is positive out there. Put in a 2 in between there. So 2 minus 3 is negative, but 2 minus 1 is positive. A negative times a positive is negative. So we know velocity is negative in there. And put in, say, 0. That'd be negative 3 times negative 1 is positive. So to answer the question in part B, the sign chart has it. The open intervals in which the particle is moving to the right would be 0 to 1 and then 3 to 5. This is where it moves right because its velocity was positive. Okay, sorry, moved a little fast there. Part C, find the velocity when acceleration is 0. Velocity when accel equals 0. Well, so what we're going to do is take our a of t function and set it equal to 0. Remember, a of t was 6t minus 12 from way up here. So 6t minus 12 equals 0, 6t equals 12, t equals 2. So at t equals 2, acceleration is 0, so the answer to this question is v of 0. I'm sorry, v of 2. So v of 2 is, well, okay, v of t was, this is way up here, 3t squared minus 12t plus 9, so I'm just going to plug a 2 in for those t's. That'll be 3 times 2 squared minus 12 times 2 plus 9. Okay, and that's going to be v of 2 equals 3 times 4 is 12 minus 24 plus 9. it works out to be -3. And what -3 means, it's moving 3, and I don't see the units here on this guy. Hold on. Okay, I don't see any units, so it would be like centimeters per second or something like that. But it's moving in 3 at a velocity speed of 3 in a negative direction, so it's moving left. Okay, so that's all of 81, and hopefully you can follow all that. 82, 3, and 4 are more problems like that. So just a brief heads up on those guys. 82 says do the same thing I just did on 81, but do it for this function on the interval 0 to 5. Well, I will tell you that if you square out the t minus 3 and multiply all of that by t minus 1, I'm going to save you a few steps, you get that. T cubed minus 7t squared plus 15t minus 9. So instead of starting off with this function and working with it, just start here and work. All right. Okay, that's the basic hint on that one. Number 83, a particle moves along the x-axis. They give you the v of t, and you're finding acceleration and position. Acceleration should be the easy one, because to get to acceleration from velocity, you're just going to say a of t equals v prime of t. You're just going to take the derivative of that, and that's pretty simple. To find v of t, to find the position function, x of t, you'll have to integrate. X of t is the integral of v of t dt. When you integrate that, you're going to get a constant that pops up in the integration. And what's going to help you get rid of the constant is this fact. At time t equals 1, the position is 4. What you've been told here, in other words, is that x of 1 is 4. And that information will get rid of your plus c. Okay, on problem 84, you're starting at acceleration. So you're going to have to integrate twice here. Once to get velocity. When you do that, you will pop up a constant. And here's the key to this problem. This particle is initially at rest. Initially at rest tells you that v of 0 is 0, and that will get rid of the constant you got when you integrated your a of t. Well, now you've got some v of t function, and you will integrate it to get x of t. X of t will have a constant. You will use this to get rid of the constant in x of t, because this tells you x of 0 equals 3. Okay, so that's rectilinear motion. It's just position, velocity, acceleration, but instead of moving up and down with free fall, you're moving right and left along the line. Okay, good luck on that. I will tell you that in the Riemann sum area, it asks you to leave your answer as a sum of products on all of the Riemann sums you're doing, and you'll understand Riemann sums hopefully after that video. What sum of products means, it might be something like you're approximating an area as a sum, so the area might approximately be 2 times 3.1 plus 4 times 19.5 plus 5 times 15. That's a sum of products. Actually, in yours, this number right here will always be the same. So if it's 2 there, it'll be 2 there, and it'll be 2 there because it represents a width of rectangles that are all the same. But that's a sum of products. Okay, good luck on all your homework. Please work. Please check your answers. I will see you on Friday.